in this session we study about the types of functions. Look at in this chart, we have given some major functions what we have to study in this session. Look at these here: the constant function, identity function, modulus function, greatest integer function. It is also called floor function. The smallest integer function, which is ceiling function, fractional function, fractional part function, signum function, exponential function, logarithmic function, reciprocal function, polynomial function, linear function, square root function, square function, cube root function, and cube function. These all sort of functions we have to study our next 4 sessions. In this session, we would study about these 3 functions: constant function, identity function, modulus function. Now, look at it, this diagram, this picture. I think you have seen this picture in art galleries. It's a modern art. No, it's not a modern art. It is the state of functions in one graph. There are so many functions I have drawn in one graph. I explain you some of the functions here. You see here, it is the horizontal line which is parallel to x-axis. This is our x-axis and this is our y-axis. So this line is parallel to x-axis and it is f of x is equal to, it is a constant function. Would be like this, always parallel to x-axis. And here you see this transverse line which is passing through the origin. It is our identity function. It is f of x is equal to x. Look at this. And this line and this curve is f of x is equal to x power 1 by 2. It is the square root function. And this is green curve, f of x is equal to a power. It is an exponential function. Here you see this the this curve f of x is equal to x cube. It is x cube. This curve, whole curve, is x cube. The cubic function we have, and this is our signum function. F of x is equal to mod of x over x, and this is our logarithmic function here. F of x is equal to log x by c. This is our reciprocal function. This one is reciprocal function. So both the sides, the opposite of the origin. And this is a thin line is the modulus function. F of x is mod of x. And this yellow curve you see here, it is f of x is equal to x. This is the quadratic function we have. So I have drawn so many functions in one graph for your better understanding. Now we study in detail about each and every function, their domain, their range, and how we draw the function graph on a graph paper. So let us first we start with the constant function. Studying first the constant function. Here first I would like to define the constant function. If c is a fixed real number, then a function f of x given by f of x is equal to c for all x belongs to R is the real number. So look at in this figure, this is our x-axis, this is the horizontal axis is our x-axis, and this is the vertical axis is our y-axis. This is our origin. Now I would like to explain with, look at one example we are taking that. F of x now we are taking one example. F of x is equal to 3. If I have 3, f of x is equal to 3 because f of x is also called y. It is mentioned by y. So we have y is equal to 3. If we plot this graph, y is equal to 3, so it is 3, and this is our y-axis. We have this is our y-axis and this is our x-axis. So here y is equal to 3, y is equal to 1, y is equal to 2, y is equal to 3. So the line will pass through these 3 always. So I draw a line here. Just a moment. This is our line we have drawn here. This is our line. This is the, you see here, it is y is equal to 3. The line is passing through 3 always. If x is equal to -5, y is equal to 3, x is equal to 3, y is equal to 3, x is equal to 4, y always y is equal to 3. So it is a constant function graph we would make through this. Now we find out the domain and range of this constant graph. So I would like to explain about this domain and range. Domain, if we study about the domain, you see the domain is this parallel to x-axis, and it is the line, and it is the x-axis also a line. So it is infinite, minus infinite to plus infinite is the domain. If you take any point, you will get always 3. If we have C, so we could assume that it is equal to C. We write in this way. If we take as a C, so it is called C. So this C would be the domain, and C would be the range of this function. So the range is always denoted by y coordinate. So the domain is parallel to x-axis, this line. So the domain is R, minus infinite to plus infinite. So domain we have R here. Domain is R, and range. Range we have C. C is our range. C is the whatever the constant is there, that is our range. So in this way we could easily find out the range and domain of the constant function. The domain of the constant function is always R, and the range is the constant, whatever the constant, that is called the range of the domain function. Here in this function, you see the domain is R and the range is 3. If we take y f of x is equal to 3, 3 is a constant, so the range is 3 here. Now we study the next function, which is the identity function. Identity function, first I want to define that associates each real number to itself is called a identity function. The function which associates each real number to itself and is usually denoted by I. Thus f of x is equal to x for all x belongs to R. So x is the domain belongs to R for all. It is the domain is mentioned here already in this definition. So I would like to explain f of x is equal to x, and you know that it is equal to y. So y is equal to x. We have we draw some graph. If we take x is equal to 1, I change the color first. If we take x is equal to 1, if we put here 1, y is also 1. If we take x is equal to 2, y is also 2. If we take x is equal to 3, y is also 3. Similarly, if we take any negative number, x is equal to -1 or x is equal to 0, so y is also 0. Yeah. X is equal to, if we take the negative number, x is equal to -1, y is -1. X is equal to -2, y is -2. X is equal to -3, y is also -3. The same number would be there. The reflection of that number would be there in a y coordinate as per the x coordinate. So now we plot these numbers here on this graph. These are our x-axis and these are our y-axis, and these are our origin is here. So I plot x is equal to 0, y is equal to 0 here. This is our x and y is equal to 0. This is our x is equal to 1, y is equal to 1, x is equal to 1 and y is equal to 1 would be here. And x is equal to 2 and y is equal to 2 would be here. X is equal to 3 and y is equal to 3 would be here. This we have plotted here. X is equal to -1, y is equal to -1 would be here. x is equal to minus 2 and y is equal to minus 2 would be here, and x is equal to minus 3 and y is equal to minus 3 would be here. So these points we have plotted here. Now we draw a line through this point. So the line would be like this. So this would be line we have. This is our graph of identity function would be like this. Now we find out the domain range of this function. As far as ux on x-axis, this line is going both the sides infinitely along the x-axis you see here. So the domain is R here. Domain is R here, and range you see it is also going infinitely to along the y-axis you see here on the both the sides. So it would be R also. The domain range both are R here, or both are the real. Now we study about the modulus function. Now look at it, this modulus function. First I would like to define the function f of x defined by f of x is equal to mod of x, where it is x when x is greater than or equal to 0, it is minus x when it is x is smaller than or equal to 0. So this sort of function is called mod of x. Now first we would draw this function on this graph. So again I would like to tell you, this is our x-axis and this is our y-axis here, and this is our origin. Now we start with this. We have f of x is equal to mod of x. This is the absolute value of x, or f of x is called y. If I put, so we have y is equal to mod of x. So if x is equal to 0, then y is also equal to 0. If we put here 0, y is 0. If x is equal to 1, so y is also 1. If x is equal to minus 1, then y is equal to mod of minus 1 would be the positive number. Always we have to take the positive number. So y is 1. X is equal to 2, so y is 2, and x is equal to minus 2, you see y is 2. Always we get the positive number, y. So if you plot these points here, so you see, we plot x is equal to 0, y is equal to 0. So we are plotting here, it is x is equal to 0, y is equal to 0. Then x is equal to 1, y is equal to 1 would be here. Then x is equal to minus 1, y is equal to 1, x is equal to minus 1, y is equal to 1 is here. So we get here. And x is equal to 2 and y is equal to 2, x is equal to 2 and y is equal to 2 is here. And x is equal to minus 2 and y is equal to 2, x is equal to minus 2 and y is equal to 2 would be here. If we draw a line through these points, so we get this graph. So here you see it is the graph of a modulus function. It is on the upper side of x-axis. So The domain is along x-axis both the sides. You see it is infinitely minus infinite, so plus infinite along x-axis it is going both the sides infinity. So domain we have R, but the range you see it is 0 to infinite on the along the y-axis, only in positive direction, not downwards here. So the domain range would be, domain of this function would be R, because the R it is along x-axis going both the way, minus infinite to positive infinite, negative infinite to positive infinite. And the range, if we study about the range, talk about range, then you see here the range is 0 to infinite, the positive direction, only in positive, not in negative direction. So the range is 0 to infinite. 0 is included and infinite never included. So 0 to infinite is the range and the domain is R. So here in this session we have studied all three types of functions, constant functions, then identity functions, then modulus function. In the next session we will study some other functions. Thank you.